Okay, so this is a new / old thing. So I'm going to write the word recall over here, but don't feel bad if this is not totally in your mind. I know you guys don't use the vocab much. So the thing I need to remember the definition for is a monomial. Ooh, I know this? Okay, good. So a variable is an example of this.
No pluses or minuses or things separating terms.
Good. There's one term. That's good. So what else?
No multiplication or division.
Yeah, like an x is an x squared. So is x squared a monomial?
No, that's a binomial.
That's a binomial.
Has a constant.
Because there's two terms, right? So a constant is one of these. So a number, a variable, what did we decided x squared was?
A monomial.
Yep, so a variable to a power.
Because it's just multiplication.
Uh-huh. And so a monomial is a number, a variable to a power.
And,
I suppose I should say or.
and a square root.
No square roots allowed. Or multiplication of
Fraction.
a number
Less than 1.
and a variable to a power.
Huh.
It should be noted that power is possibly 1.
Oh, it's like 5x.
Good, perfect. So let's make an example, not example list. Okay, so Gibbs says 5x is an example. I agree. What are other examples that we talked about while we were making this?
X1.
So we talked about x briefly.
5.
5. Sure, because 5 is a number.
2 to the x.
Ah.
That's exponential.
Yeah, so is 2 to the x, right? Is that a number?
A constant.
Yeah.
No, right? 2 to the x isn't just a number, right? It's a number to a variable. So is it a variable?
No.
No, it's a number to a variable. It's not a variable to a power, right? Because the base of the exponent is a number. And it's definitely not multiplication of things like that. So 2x is over here. Exponential things are not monomials.
Yeah, I figured because with 2x, you said before the square roots aren't allowed in this, and 2x can be a square root. 2 to the x can be a square root because x could be a fraction. Because something to a fraction power
I don't
is the
think
same
that
as
logic holds up because 5 is also the square root of 25.
Yeah, so not terrible logic. A little bit troubled in that I said square roots of variables are not allowed. So don't conflate this one, square root of x, right, which is x to the 1/2 power, right? That one's not allowed.
Would 5, square root of 5 be good then?
Really, I should say that the powers should be natural numbers, right, to be totally precise here. So is square root of 5 one of these or one of those?
It's an example.
Yeah, square root of 5, right, is a number, messy though it may be. And so it falls under the number category here.
And it cannot be a negative or a plus or minus.
Yeah, so plus or minus isn't a number, it's two numbers, right? So like if I write plus or minus 2,
That's
Okay.
plus 2 and minus 2.
that's one of these guys, because it's two things, right? It's not one number. guys cool with that? Infinity also goes over here. I mean, we have lots of kind of labels that we use, right? That don't represent things that aren't quite numbers.
What about pi?
Ah,
That's a number.
pi is a number. Pi goes over here.
What about
Sure.
Zero.
I'm going to put negative pi in there. Yeah, is 0 a number? Yes, absolutely. 0 goes over here. We could continue listing all the numbers. Okay? Keep in mind that really messy crap, like the log of 3 to the 27th power divided by pi times 43 all to the 1/2. Like,
That's a monomial.
yeah. This shit is a number, right? It's a really messy number, but it's just a number. That's cool. So even the messiest numbers you can imagine, square root of pi to e to the 53rd and a half power.
Oh my god.
This is a number, right? We could continue listing all the numbers. There are actually interesting questions about numbers like this, e to the square root of pi. There's a very weird thing that some of the numbers in this class we're not sure whether they're fractions or not. So, you guys good with this? Oh yeah, I'm sure. Yeah, towers of powers make overflow errors in calculators really fast.
Oh, yeah.
It should be noted that things like this, x to the 1001, fall under the example side rather than the non-example side, right? We should put, Gabe had earlier an example that I said was over here. Do you remember what it was, Gabe? Yeah. X plus 1 is not a monomial, right? It's two monomials added together. So that's what we call a binomial or a polynomial.
That first example you gave, the messy number, by the way, it's like 2.55.
Yeah, I mean, probably approximately, sure.
I love that we're all trying to find that.
They're numbers, who cares? Not an engineer. So, polynomial, what's a polynomial?
Many nomials.
Yeah, so a polynomial is a sum of monomials, and it should be noted that this sum has to be finite. Okay? The only reason I'm mentioning that right now is for you guys, I gave those things in Demavros, right? Remember when I was explaining Demavros, I said we could, if we were in calc class, we could write down e to the x as 1 plus x over 2 plus x squared over 6.
Oh, yeah.
Or, yeah, I screwed up the powers in saying that, but we
Yeah,
could
I
write down this infinite polynomial. That thing is not actually a polynomial because it has infinitely many terms. Okay? So e to the x is not accidentally a polynomial. We can make a polynomial approximation to it by cutting that thing off, or we can make a Taylor series by leaving the whole thing, but that is not a polynomial. Is all cool with that?
So that's kind of like restricting the domain and range for sine and cosine kind of thing.
Yeah, if we want to get an approximation, we could truncate it, which is actually how your calculator does that.
Okay.
Like when you punch the E button in your calculator, it doesn't have a magic way to know what E to the number is, except to do that Taylor polynomial. Calculators are dumb. They can only actually do one thing, which is add. They can't actually multiply, they just add a bunch of things. So, yeah. Computer science is neat. I encourage you to fall down that particular rabbit hole. So we should maybe give examples and not examples for polynomials as well. So,
X plus 1.
example. Perfect.
Plus one is
X plus 1. Excellent. Things you know and love. 3x squared plus 5x plus 7. Right? You have techniques for quadratics? Yes? Those are examples. That's good, because we know something about those. Not examples. I think I just said this one. 1 plus x squared over 2 plus x cubed over 6 plus x to the 4th over 24 plus, and on, right? What's the part of that that's making it not a polynomial?
It's continuous.
Yeah, the and on, right? So this thing truncated someplace would fall into the example category, but with the dot there, goes on this side.
So any exponential formula will be good.
Good, perfect. So exponential things, 2 to the x or e to the x, those will still fall on the not example side. Cool. Other things?
Any other thing that's going to go on forever? What about like numbers kind of like pi, how they just keep on going on forever?
well, it's still a number.
Yeah.
Yeah, it's still a number, but I mean, like, is there anything with that that's not going to be working well?
Nope. So numbers like pi, although the decimal expansion continues infinitely, not a problem here, still just a number. So pi is a really boring polynomial, right? Because specifically it's a monomial, right? So keep in mind that all the monomial examples, right, all of these guys, they also go in this one too, right? They're all polynomial examples. You guys cool with this? Okay, how about for kicks, let's check another one. So I just want to check our understanding just time a little bit. So is x over 3 a monomial, a polynomial?
We'll say mon.
I say fine.
Ah, good, you're both right. This is a monomial and also a polynomial. Why am I not worried about the fact that there's division when my thing says multiplication?
Because
Multiply
division is
by
another
You can put it to the power.
Good, you guys are super bored by that. Excellent. So you think about that as 1/3 times x to the 1 power, right? So here you have a number times a variable to an integer power, or to a natural number power. Perfect. How about is 3 over x a monomial, a polynomial?
Neither. Does x to be 0 and it screws all thing up.
Ah, cool. Yeah, so that's another thing you could use to check. The domain of polynomials are all real numbers. This thing does not have that as a domain. Specifically, what is the problem here?
0.
Yeah. X is 0 is causing me a headache. What is the, so why isn't it a monomial though?
Because it's not a number, really. It's
But it could be 3x to the negative 1.
Good, I could rewrite this, yeah, as 3 times x to the negative 1. Why does that not pass?
Because of the non-infinite domain.
Yeah, maybe more precisely, the powers are supposed to be natural numbers, right? Counting numbers. That there is a integer, not a counting number, so, whoops,
So is that
wrong
why?
deal.
So is that why they say it can't be an integer? It has to be natural.
Yep. Yeah, that's why I fumbled when I said it. When I said, oh, whoops, no, natural power, not integer power, because that makes a big difference here, right? I really want statements like the domain of polynomials are all real numbers, right? That's going to be true as long as I don't allow division by variables. If I allow division by variables, then I'll have this, well, it's less than bottom 0, and I don't want to deal with that shit. Cool. So this is, no, it's not a monomial. Is it a polynomial? No. It's not a monomial. It's definitely not. Right? It's one term, right? Yeah. So it's also not a polynomial.
Is that why the square root of a variable is also in the not an example because it doesn't have an infinite domain?
Sure. Yeah, you could look at it that way. Do keep in mind that not everything with a domain of all real numbers is a polynomial.
Like
Right.
sine?
So polynomials, they take R somewhere. That's true. But not all things that take all of R are polynomials. These guys, for instance, right, have a domain that's all real numbers, but they're not polynomials. So it's a quick check, but it's not a definitive check. Does that make sense?
So it'd be more to like something to a fraction power is not a natural number.
Yeah. So I would say that as a square root is not a monomial because the power on that variable is not a natural number power. Cool. Questions, Steele?